Hello and welcome back to the YouTube channel from Jörn. My name is Kai Reinke and I'm very happy to see you again here in this place. Today I want to talk about our bicycle project. Well, we don't want to offer a bicycle itself to the market, but we have invented a suspension for a bicycle. Before I want to talk about the technical details, I want to tell you a little bit about the story of how this started. But just for information, and you can see three parts here on the table. And these are the parts which are developed and used in the bicycle suspension. This is the V-mount. This is underneath the saddle. You see a small slit bush. And if you want to learn more about the functionality of the slitbush, please see our latest video, which we have posted, I would say last week. And this is the main suspension element. That's again a slitbush, and that's in the pedal bracket housing. Well, the story of the Jörn bicycle suspension. Well, once upon a time. Thomas Uhlig and myself, we were on a business trip, sitting for many hours in a car. Thomas Uhlig, he was a bicycle racer, an amateur racer, but a successful sportsman in this area. So he has a bicycle history. I myself, I was a triathlete, where also cycling is part of, as you know. So we're thinking about and discussing during the long drive whether there's any chance to combine what we're doing today in a business, like developing rubber metal parts, with our hobbies, bicycling, cycling. And so the idea was born to invent a bicycle suspension. And Thomas Uhlig, the design engineer here, he was the man who finally made the concept and did all the drawings and the calculations and these kind of things. He designed and developed this application. What was the goal of our idea? Well, we wanted to increase the comfort level for the people who are using the bicycles on a daily basis for like commuting, go to work in urban applications as urban bikes, for trekking bikes and these kind of things. And very soon we came up with the idea that it might make sense to increase the vibration comfort for cargo bikes as well. Because cargo bikes nowadays are more and more used as business applications. Well, that's a very artificial word. But they're more and more used for cargo services. So the people are doing their work on the bicycles. And as soon as a bicycle or whatever becomes an apparatus for work, some other rules are going to be applicable. So there's a vibration level which must not overachieved during a daily utilization of an apparatus or machine. So in other words, once you have achieved a higher level of vibration than allowed, you have to stop your work, which is of course not very efficient for doing the work. And applying a very smart suspension system could help reducing the vibration level to make to move you into a position where you can use your cargo bike more working hours a day. That was the motivation, and now I want to go down and I want to show you the bicycle itself a little bit more. Thank you very much. Okay, now as promised, we're here and looking at the bicycle itself. As I've said, it's a little bit dirty. That's because of the latest test rides we did. We haven't cleaned it up since then, sorry for that. But however, that shows it was really in use. Let me say something about the environment where we are here now. This is our test bench, our test benches for durability testing. In this location, we destroy the parts we're going to make, we produce. Doesn't sound very nice to make them break. However, only if you know how many load cycles, at which load the parts are able to bear, you really fully understand where the limits of the parts are. And that's what we also did with the parts we are using here in the bicycle for the suspension. The bicycle frame, of course, is a Jörn design as well. Thomas Uhlich has designed that and he has calculated with the FAA calculation method. This was very important for us because we didn't want to break the frame of the bike during our test rides. So it was in his own interest of Thomas Uhlich to make sure that this is robust enough because he was one of the test drivers. And I also was, and I also didn't want this part to fail. Let me now explain you the details of the suspension. I will show you the parts more in detail, explain a little bit more about the functionality later on when we're back in the office. But here we have the slitbush in the pedal brackets housing. And we have the chainstays fixed to the inner tube of the slitbush in a way that the chainstays can twist by about 5 degrees around this housing. Then we have the main spring element. That's the V-mount inside here of this box. That allows the springs to travel. That's the flexibility. You can show how you will see how it works later on in the video when you see the video part while I'm cycling. In order to allow the kinematic to work, you need twisting angle here as well. So that's about 2 degrees, and that's a very small slitbush inserted here. Well, the frame and the housing of the spring element looks rather big and maybe not that smooth, not that nice. Well, I mean, number one, we are not designers, we are engineers. That's one reason. And the other thing is, we wanted to build the housing a little bit bigger from the beginning because we want to be as flexible as possible. We want to try some things, and we didn't want to build 2 or 3 or whatever frames. One was enough. And later we learned that you can build that much smaller, much smoother, so that in a way that it's not that big. Okay, that was the rear suspension. Let's move on now to the front suspension. Well, you don't see that much about the front suspension. You can see here this black thing. That's the polyurethane foam. That's the spring itself. You don't see the guidance because that's inside of the steering tube. I will show the details later on on a picture where it's better to understand. You can follow better. You can see the travel of that spring later on in the driving video as well. There's one important thing to understand about this system. That's the decoupling between the force transfer, the transfer of the longitudinal force, so this direction, which are coming from braking maneuvers or when you're riding against a bump or so. This is introducing huge longitudinal force, and the force are guided from the fork via the 2 bearings here directly to the frame, and it's not bypassed by the linear guidance in that direction. You will see that later in detail when I show you the picture. Yeah, well, I believe that's it for the front suspension, for the rear suspension as well. You see, it is a real bike. We've built a real bike.
maybe one or two more features. We've been focused on a very, very high stiffness in this direction in order to have not this kind of riding a horse movement while pedaling. You don't want that. That doesn't feel nice, you know. And you don't have that because it's in that direction very stiff. And yeah, also very, very stiff in this direction, and that's very important to maintain the same length of the chain itself in order to allow the gear changer working smoothly. Another very, very important feature is the lateral stiffness of that rear end of the bike. I mean, you don't want, I will try to do it like this here, again with a little bit of violence. I really try to push hard. I mean, I'm not a very strong guy, but believe me, if it's too soft, you could easily move that in that direction. You don't want that. You don't want that kind of movement because that would really lead to a very unstable feeling during cycling. Okay? That's it. Oh, voila. I'm putting that. Okay. Now, here we go. That's it for the suspension. So let's move back to the office and I will tell you a little bit more details about all the single components. Okay. But one moment, this one thing I've lost at the beginning, and it's about the noise, the background noise we hear here, because that's because of the testing environment. That's an air blower, part of the air conditioning system here in the testing chamber. That always works, and that makes a little bit of background noise. However, the test rigs itself are all switched off, especially for this movie. Take it.
Okay, friends, I'm back in the office because I want to explain a little more in detail about the functionality of the single components of the bicycle suspension system. You saw on the bicycle itself how it works in the overall setup, and you saw before the single components as well. Let's start with this one. That's the main component of the suspension. That's a slitbush. How the slitbush works, I will refer to our slitbush video here on our YouTube channel. This slitbush is pushed into the pedal bracket housing, and here inside you see the fitting room for the pedal bracket bearing. Of course, different standards are possible. We just need to know that in advance in order to adapt our tools and the manufacturing process. This bush looks a little bit, but it's used already. So we've mounted it and dismounted it, so that's why it looks a little bit used, because it is used. Actually, this slit bush is made of two slit bushes, and slit bushes like this are used in truck suspension of a 40-ton truck. And we thought if a part is robust enough for a 40-ton truck, it might be robust enough as well for bicycle suspension. The idea is to have a very, very high stiffness in that direction, which is the direction of the connection from the saddle to the pedal bracket housing, and we want it to be soft in that direction in order to allow the chainstays to move. The chainstays, excuse me, the chainstays are connected to the inner tube of the bush. So there's a rubber layer then between the chainstays and the pedal bracket housing. Of course, that's a little bit larger standard than the normal standard of bicycles, but however, a few adaptations to the frame of the bicycle are required anyway. We have a twisting angle of about 5 degrees in that case. To meet the overall function, to not overload the kinematic, we need another joint here near to the dropouts, where the chain stays are connected with the saddle stays, and that's also a small slitbush. Twisting angle here in that area is about 2 degrees. And then we have the main spring component. However, the slitbush is the core of the idea, but the main spring behavior of the bicycle is given by this V-mount. That's mounted like this. You saw that in the picture, and it's stiff in that direction and soft in that direction. That's the travel suspension, the direction of the travel suspension, and we achieve about a travel of 25 millimeters in that spring here. That's it. That's it. I believe for the rear suspension system. Let's move on to the front suspension. Since this is a little bit more complicated to show on real samples, I want to show that on picture here. It's a stem suspension. It's also maintenance free, and the design is pretty smooth because of an integrated damping to the system. The travel of the suspension here is as well 25 millimeters. However, we just started to rethink whether 25 millimeters is really necessary or if less travel would also work. Because keep in mind our original goal of the suspension, we want to improve the vibration level for bicycles on paved tracks, on gravel paths and rough roads, and not for downhill racers, you know. Okay, the idea of this suspension of the trim is to decouple the load, the longitudinal load, coming from events like braking, or when you hit with the front wheel a hurdle, something like that. And we want to decouple these loads from the guidance of this system. Because if these longitudinal loads need to be transferred via the guidance of the system, you need to design this much more robust, and this is just too big. You can't integrate that into a standard bicycle application. So the guidance is has a shape like this, in order to transfer the steering moment properly. Okay. The longitudinal loads are transferred via these two bearings here, directly from the fork to the frame, without any extra weight via the guidance. With this center bolt, you can, by tightening it, you can adjust the stiffness of the front suspension to the weight of the driver. Yeah, because light-weighted driver require less stiffness in the system. Okay, I believe that's more or less the main story of our bicycle suspension. And again, all the components are developed starting from truck parts, and what is robust enough for trucks should be also robust enough for bicycles, even for cargo bikes. Talking about cargo bikes, will not forget to mention that we are in mass production with the first application since beginning of this year, and that's for the Kettler bike, the Cargoline, where we have decoupled the front end of the bicycle and the load is decoupled. Yeah, for more details, please don't hesitate to ask us. Well, I'm in the end of my presentation today. I want to say thank you very much to my colleague Michael Schiebel for directing this movie, for doing the cutting and all the nice effects of that. And I want to thank you for your attention. I hope you enjoyed it, and if so, I would be happy if you subscribe to our channel, and I'm very happy to welcome you again for the next videos. Thank you very much.